Jean-Michel just showed us two things. One of his last slides was a diagnostic concerning user interest, which was the crash of a plane. But most of what he presented was, I would say, internal validation in the sense that he was looking for improvement of the future system using essentially the way systems are corrected through assimilation. So most of the validation task that was performed to evaluate this new system was based on assimilation. This is not exactly the way we proceed to have an overview of the quality of the products in the full Copernicus Marine Service, where we rely on different kind of approaches to validate the products, and not only the system and the forecast. So to do that, we built, from the Valuation experience we had on organizing these kind of things, two groups, one concerning the product quality and one concerning the multi-year products and reanalysis and reprocessed product. And all these activities coordinated by my colleague and myself. So the idea is provide timely, robust, and reliable products for the service in a cost-effective and useful way. And as you have seen up to yesterday, the production is distributed among different production centers, where we try to ask them to perform this kind of validation activity called the product quality activities. And once this is done, we need to inform the users. So informs on that product quality, and also find a way to get back from users their feedback and requests. So this is organized through all the different blocks of the Copernicus Marine Service organization. And in practice, the main rules we ask for the product quality were that for every product in the catalog, we will try to give some assessment and some errors or accuracy numbers. We want also that this information is clearly and fully available for the users. And because, as I said, we have many providers of this information, one of the internal work inside the project is to be sure that all this information are homogeneous and consistent. And part of the game through the every year evolution of the activity is to use this information for quality insurance, which means that all this product quality activity is part of the evaluation of the activity of every producer through reviews and procedures and so on. And another request we have in this activity is to ask all the producers to perform quality control on everything that goes into their system, and also, as far as they can, to use as input data, data that have been provided and prepared by typically the TAC, thematic assembly centers, in order to have an internal control of what is done in order to produce information for users. We have identified typically three kinds of metrics and validation approaches we need to implement. Internal, this is what the community, the oceanography community practices since work has been done in order to develop models and so on, which is to verify that the system that is designed is matching scientific requirements. Typically, is the solution produced by a model representing the ocean processes as expected and prescribed. Typically, if I want to have a climate model with a 2-degree grid, I want to see that this 2-degree grid provides solutions that are compatible with the climatic variability. And also, we want to be sure that the scales that are represented are close to the truth, but the truth that is also filtered at the same kind of at the same scale. External means that in practice the users might go to the beach and see what happens when looking at the real ocean. So we need also to inform them on the differences between what we produce and what is the natural truth, as far as we can measure this natural truth, and what are the processes that are represented into our products. So this is kind of external approaches in order to evaluate our products. And then, obviously, we have a series of well-identified community of users, and we also need to look at the quality of our product, particularly with the eyes of these users, trying to define metrics that are user-oriented in order to give them numbers that are compatible with their own application and use. So the idea is to go at sea and to measure the sea and to compare to what we are doing. So this was the old way. In practice, we are not doing that way, exactly. What we are doing is to use state-of-the-art approaches that are shared by the international community. And in particular, we had a presentation yesterday about good ocean view, where task teams are working on that kind of approaches. The World Meteorological Organization have lots of panels also talking about assessing and measuring the skill of forecast for the atmosphere. So we are trying to use this kind of state-of-the-art development. We are a community that has also a long-term commitment. We started in Valuation or before in Mercy. So we have accumulated experiences concerning the way we want to validate our systems. And then in practice, what we are relying on is to compare to first observations, second to typically what is known as a reference of the static ocean like climatology. And when we don't have this kind of information, we rely to published results. Another way also to validate the products from CMEMS is to intercompare and do some multi-sim assessment. And obviously, because we provide that to users, and last way to be aware is to look at users and expect from them some feedback. So these are some 3 slides from our colleague for the Mediterranean Sea that we are presenting what they are doing. So relying on data, typically at the surface, moorings, satellite maps, at depths, in situ profile, XBTs, gliders, and so on, or at different layers, looking precisely with dedicated observations, different aspects that can be compared to model results, and also in order to establish statistics on different areas of this comparison. So for instance, our colleagues in the Mediterranean Sea has defined areas where they accumulate comparison and compute statistics, and then these statistics are used to evaluate the systems for every parameter, and then these numbers are used to provide estimated accuracy numbers that are going to be the main values provided to users. Another example here from our colleagues in Spain, looking at the Irish, Biscay, Iberian shelf system, comparing, for instance, here the SST. So this is a map of SST, the Ostia product from the OSITAC, or comparing on the right side at mooring location, the differences between what is measured by a buoy and provided by the model. And all this comparison allows us to establish what the reliability of the different products we are providing to users. How do we proceed in real time? We have several ways to work. So we asked all these production center to perform routine monitoring, to validate the multi-year products, to implement new metrics, to perform the pre-operational qualification, and to report. Then Mercator Océan is coordinating, well, sometimes this way, but much more at the office carefully on reviews and looking at the documentation and the way the work what is done in the different areas. And we asked the Operation Center to provide documentation called the QID, Quality Information Documents. The QIDs contain executive summaries with these estimated numbers, a description of the system, validation framework, and validation results, where the expert user can get all this kind of useful information. In parallel, we are performing online monitoring through the Copernicus site. All this activity is linked with the service desk that communicates with users. And as I said, we have the product quality working group, which are a group of experts that are going to design all the validation plans for every system that are going to be used for carrying out all these metrics and the validation activities. And there is exchanges between the coordination team and all these activities. So if you go to the Copernicus website, you will see that there is validation statistics. Typically, you will find this page. And if you look to the Northwest Shelf, for instance, system, you will have the statistics over time at different depths for different parameters. We are improving that in order to provide a more user-friendly mapping tool, integrating new metrics and linked with the catalog. And also we plan to link that with regional websites in order to better zoom on different areas, different parameters, and typically providing numbers that are more interesting for users in terms of accuracy and zooming at different areas, at depths, and so on. So we are also working on new metrics and new validation approaches. So this was, for instance, discussed at the last TAPAS meeting, where using a series of altimetric tracks that provide sea-level anomalies, we are now looking at the content in terms of scales and a different resolution, and trying to see what is the scales content on the different system compared, for instance, here to the altimetric data set. Another example of what we are trying to do is to compare a different, on different areas the water mass content, and looking the different kind of water masses that can be represented by our system in Uncast and Forecast compared to the existing data. Also user-oriented metrics, for instance, maybe you saw that yesterday afternoon. This is the differences between the sea ice edge, which is quite important for ship routing, and the effective representation of this sea ice edge using the current system presented by Jean-Michel, and the distances between the real sea ice edge, observed sea ice edge, and what the model forecast. Or here, another kind of approaches, contingency matrices, where we try to identify between the model and the observation where we match reality when there is an observed phenomena or not. And in this case, for instance, the yellow is bad, and the red and the green is good information for users. So another way also to look at these kind of things is to be interested in the surface currents. Here, drifters, and what we are doing here is computing simulated trajectory using the surface current from the model and compare to drifters and identify the dispersion and where we are good or bad in terms of representing, for instance, search and rescue activities and so on. So to conclude, this product activity in CMEMS is a core activity and is the marque de fabrique, I would say, since Merci. It performs at every level and is part of the quality assurance. This is an expert activity linked with the international community, and we try to link them with the user needs, their feedbacks and requests. Thank you.